Hello guys, welcome back for the part 3 of the system design for a key value store. Now, where we left, now we have to cover the partition lookup service and the database design, right? And okay, yeah. Now, we have discussed about the different strategy for partition of the databases. Now let's just discuss, the service discovery mechanism, how the web application server node get to know which node it has to connect and route the request to, right? For a given a key value, which partition is hosted on which node. Okay, so whenever so this would be a sort of in a cluster, Dynamo DB database cluster. We would be having some sort of in a cluster, and you can call it a node, database node only, not a dynamo node one. And in that cluster, whenever new node will be joining, what it will do, the basic first bootstrapping thing is to update into the partition lookup service. Okay, this is the a sort of in a range, and probably the range will be assigned later on, but it should update. Hey, I am the node number this, and I have this IP address, and I have this uh, basically IP address would be updated, and these are the node number would be updated into the partition lookup service, right? And then partition lookup service would be responsible for would be responsible for assigning the range to that, to those nodes. Okay, this set of an range would belongs to this node, and the other set of partition being hosted onto that node. Okay, so partition lookup service would be maintaining all of those information. So whenever the new node will go away, now then the these node also always keeps on pinging every frequent interval of time. It will update, let's say every 1 minute or every 50 second or 20 second. It will update into the partition lookup service. Hey, I am alive, because node can go no node can go down at any point of the time, right? And how does a partition lookup service will get to know this node is down now, right? Basically, whenever the node is being joining that cluster, its responsibility is to update into the partition lookup service, as well as every frequent interval of time it keep on updating the ping into the partition lookup service, so that partition lookup service is always up to date. These nodes are alive, and these the nodes having these set of in a range. Okay, but these service can also be responsible, this coordination service can also be responsible for electing the leader as well, right? If because let's say partition this service find that it has not got the ping from the node number 2, it means the node 2 is down. Let's say for a 2 to 3 minute it has not got the ping, the node 2 is down. Now it has to, now partition local service must be knowing ki what sort of partition the node 2 was holding on, and which one was the leader out of them, right? Now node partition lookup service or this coordination service can take a responsibility and electing the leader from the other replica of that partition, right? So it can make, probably node 3 would have that replica of that partition uh, of the which were on the node 2. So node 3 would have the replica of it, and then partition this coordination service can make that particular replica, which was a follower into the node 3, make it as a leader now. And now every new request for that particular partition would route through the node 3, because that would be a new leader now, if we have chosen the leader in partition strategy, right? Now so the partition lookup service, now you can ask me, say, uh, the, this is a single point of failure, the partition lookup service, right? We may bring some more nodes, but we have the important concept point that has to be remembered here. If we have even let's say 3 nodes of this partition lookup service, to bring the high availability, but it has to be highly consistent. It has to be highly consistent. We cannot keep these as an eventual consistent, and we cannot partition this data as well as also, because the data would be very small, and the data would be very small. What data it would contain? It would contain the it would have the some tables, the node 1 this is the range it is keeping, and this is a leader partition into that. This sort of information it will contain to. But every service will having the entire copy of the data. We are not partitioning it, because if we partition this data, when do we do a partition? When we have a lot of data we cannot handle on the single node, right? But this is very small set of data, and ideally we cannot partition that data. If we have partitioned the data, then web application does not have any way to figure it out which partition has that information, which node is being hosted, which node is hosting which partition of the database, right? Because web application always have a key. It will always have a key, given key and value. Now we were knowing that using the key, we were figuring out which partition it may belongs to. The key were always being given to us, right? Now, so hence we cannot partition the data. Entire data, let's say partition lookup service has a 1 MB of the data or 100 MB of the data. The entire data has to be replicated across all of the nodes. Okay, and it is a this part has to be highly consistent. When I say highly consistent, so there would be one of the master of it. Let's say this node is a master. We can follow the something like master and follower pattern here. So this can be the master, and the another node can be the replica of it. And let's say we are having uh, three nodes, right? So all of them can be uh, failover node, or you can say read replica, right? And this has to be the master. So every write operation has to go through this, but we can read from the other node as well also. So whenever we are writing, this node will be synchronously writing to this node as well also before returning the response to the database node and accepting their wings. And if the the replica is not available, it will fail and write operation, it it will not accept that request until unless being successful to all of the node. We have to keep this highly consistent, because if this becomes a inconsistent or eventual consistent, it might be highly possible during the read request, we may have the older version of the node that was hosting the partition, right? And we may fetching from the wrong node, get me the key or value of the given the key. We were we were probably we were going to the older node, right? Because the newer node could have been updated, because older node may have went down, and we that there was an election happened, and due to the eventual consistency, we are not keeping every replica up to date. So when there is a read request on the web application node, it may go to the read replica that has the older version of that copy. It will figure it out. Okay, then node one has that the hosting the partition for given this key, but actually it was the node two was elected as a new leader, and it was node two was hosting the partition for that key, right? So hence, so that is the reason we are choosing the eventual consistency here. That is fine, but we cannot choose the eventual consistency here. We have to keep it highly consistent, and every write operation to it has to asynchronously happen to all of the node. And but we can these services are very lightweight only, because how much data it will have, we I mean it will be very probably 1 GB of data, and not even 1 GB is too much high. What data we are keeping to it? Let's just take, I mean, I've created a table using the chat GPT, right? So it may have these sort of informations like, range 1 to 10, partition 1 belongs to node 1, and IP address is this, right? So the whenever given a key, I will figure it out, the token out of it using the consistent hashing and MD5 algorithm, figure it out which range it belong to, and then I will using the, let's say it is a 75 key, and I'll go to the my one of the read replica of that partition lookup service. In that partition lookup service, since all of the data is entire copy of that is present on the all of the node, we can go to any of the node, right? I don't need to figure out the partition of that, and we are not partitioning the data. So let's say it went to the one of the read replica, and using the 75 key, it find out, okay, this is the node one which are hosting the partition one. Okay, and now it know which what is the IP address of that particular node. So it go to that particular node. Now after fetching the data from partition lookup service, first it will make a call to here, and then it will get a response from this, and then it will make a, once it get a response, then it will make a update, write to that particular node or read to that particular partition or node of that database cluster, right? So, I mean, we can have, I mean, since we are also maintaining the followers, so we can have something like this. So range 1 to 100 range, partition 1, node 1 pair. This is a role is a leader, partition 1 is a leader, and same range 1 to 10, partition name, yeah, same partition. The replica of it is on node 2, but it is a follower. So these are the table would be maintained into the, this sort of a table would be maintained into the my partition lookup service, right? And so yeah, now uh, there's a couple of ways. I mean, do you see? I mean, I have removed that single failure point here. If I would have a single service discovery node, this would have become the one of the bottleneck and the single point of failure, right? Which generally in the case of a distributed system, we don't want to have the single point of failure. Hence, we have a multiple nodes, and we are keeping the highly consistent as well also. Now, okay, so we do not have any single point of failure here. In the database node as well, also we are replicating to the different partitions, different followers. For each partition, we have a n number of n replicas. So this is, and it is also horizontally scalable. If you bring a more node, it will also adjust and redistribute the range of tokens between them, and then it will also scale your operations, right? Web
One
applications are
question
the,
here.
yeah,
Can you open that table once again? Partition lookup table.
yeah,
Yeah. So in this, like for partition one, both node one and node two, one is leader and one is follower.
right.
So who will decide the like there is one read operation from the web application? Is that zookeeper service or the partition lookup table is deciding like which node it will give? Like who will decide which partition the read will go to, whether it will be the leader or follower? Like
But
it can't send all the reads to one node, right? Because then it will become a hot partition.
yeah,
Who
so
will take the
in
decision?
the case of a write, it will always go through the in if we have chosen the leader and follower partition strategy. In the case of a write, the write will always go to the single leader, okay, the leader
Right.
partition, right? But the read can happen through the any of the either through the leader or through the follower as well also, right? Now it can go to any of the any of that replica of given that partition and fetch the key out of it, uh, right? So
Okay.
in the case of read, did I
So
answer your
which
question?
node will it return? Like
It
which
can
like who will take that decision? Like
so
it can direct all the read to node two, then node two will become very hot, right? With all the reads.
so
So who is the
basically,
do the load balancing? I'm asking.
yeah, they could. So I mean, here in this case, zookeeper has this information, right? And it can
Hmm.
return whatever, I mean, and so let's say no, partition being one is being hosted on node one as a leader, and rest of the node as a followers. So all of the node can be written to it. Now in that case, it just have the IP address and port, so it can connect to any one of them. But obviously, I got your point. We would have some load balancing of it, so we may have the some
Right.
load balancer as well also, right, in front of
Right.
in front of my database nodes. But web application would know ki which nodes it to connect, so the load balancer can forward that request to that particular node which has this IP address and all,
Right.
right?
So yeah.
uh,
Also we were using
Also,
I think leaderless in
yeah,
Dynamo.
yeah,
So there we will have multiple reads. Like we will
right,
use quorum there, right?
right,
We will
right,
send my read request to multiple.
right.
Okay, got it.
uh, and then in the case of quorum, we will have a high chances of conflicts as well also, so we'll have to resolve those conflicts. So, but that would be also preferred for a high available systems, right? But in a case of in some cases we can go with a leader and follower if we want to avoid conflicts and all, because conflict resolution is much harder to resolve as well also, right? So yeah. So partition lookup, we spoke about the partition lookup service in depth about it, how this service is being maintained, and right, and how why I've chosen the highly consistent as well also, and the data is very small. We can replicate across all of the need entire copy of the data, right? So. So but there is a one of the bottleneck that I see here is that every request that has on the come to the web application node has to connect to the first partition lookup service to find out that particular node and then make a call to the particular database, right? Database node partition. I mean, I can think of many number of ways I can, avoid, contacting every time this partition lookup service. Okay, there could be another strategy as well also. So rather web application node is being fetching. What if so every web application can maintain first time, let's say it fetch the copy, the latest table from the partition lookup service and maintain in their own RAM, right? But uh, it might be possible that every second interval of time that partitions lookup service data is being getting updated, because in the case of in a dynamic world the database node can go down, up and all, and the IP address range, all of that can rebalance, and so the data can keep on changing it. And so partition lookup service is up to date, but we'll have to keep the web application node also up to date. If we, let's say, uh, if we wanted to cache into the web application as well also that these information that partition lookup service has, so that we can avoid every uh, uh, for every call we can avoid making a request to the partition lookup service if we can cache the information in the web application node itself only, right? But how we will handle the updates, because we'll have to keep the data also up to date, right? So what we can do, there is another way. Whenever there is a change in the partition lookup service, we can update into the all of the web application. So rather web application fetches from every time, it's like a push mechanism, right? We earlier we were doing a pull mechanism. We can do the push mechanism from the servers to the web application, right? Whenever there is a change, it will update to the web application, right? All of the node, right? There can be the mechanism how we can do it. Either we may have this, whenever there is a change, we can emit an event. That event could pass through the Kafka, and these web application node can consume from that. That could be one of the way. Another way is whenever there is a change, we can make a now there would be, obviously we need the partition lookup service would be has to know which services it has to connect, what are the IP address and port. So again, for a web application nodes as well, also there would be a service discovery, right? So using that service discovery, we'll update to all of the web application nodes using just an HTTP call and all, right? So that way we can update that. These are the two strategies, right? One is that pull based mechanism and one is a push based mechanism. I would go for a push based mechanism because uh, it might be possible that for every request they may not be changed into the partition lookup service, right? So we can maintain that copy of the data in the web. Whenever there is a change, they will update to it. So we can still avoid lot of calls where there's no change into the partition lookup service, and we can that cached version of the copy we can make a directly call to the DynamoDB itself, right? So these are the strategy of pros and cons. The benefit out of it, we can see, decrease the latencies of our system, because these were adding the another hop into that, and it increasing the latency for each read and write application, write request. Now when we are maintaining on the node itself also, I mean, you may ask you how much size of the data it would be. It would not be more than a 10 MB or 50 MB of the data. If you think, let's say we are having 1,000 nodes here, one node entry, how much it would take? 1 KB, right? So if we are having 1,000 database node, or even you assume that 2,000, 5,000, 10,000 nodes, a hypothetical situation, 10,000 nodes. Here we can have a 10,000 nodes. So 10,000 nodes each would take a 1 kb of an entry into a partition lookup service. So 10,000 into 1 kb is how much it would be? I think 10 to the power 1 MB worth of data. It's 10,000 is a 10 to the power 4, and 10 to the power 3 is a 10 MB worth of a data. 10 to the power 7. 10 MB worth of a data is still not very high. So we can keep, you know, entire copy being replicated across all of the partition lookup service node, and we can, whenever there is a change, we can update into the web application itself, right? So push based mechanism, right? So yeah, I think we have covered these of the strategy. Now, but there's a yes. Now the web application has become a stateful nodes. Okay. Earlier it was an stateless node, so it was horizontally scalable, highly scalable, but it has become a stateful node. So whenever new web node will come up, first time during the bootstrap, it has to fetch the entire copy from the partition lookup service, right, and maintain in their local cache. So this is the additional operation, but it would be a one time only, not for every call, but only one time, right? So still it's fine. But I mean, ideally you should discuss this is the way you would do it when you are using the push based mechanism, right? And okay, so we have spoken to partition lookup service, database. Yeah, authentication authorization is a very generic service, and we have a Redis cluster. So assuming we have 1,000 requests, read write requests per second, and 10,000 requests, read query per second, it might be possible some of the key are very frequently accessed, so we can keep that into the Redis cluster itself only, and we can also have the TTL for it, time to expire, right? Let's say 5 minutes, 10 minutes, we can have a time to expire for it, right? So we do not have to go through web applications and DynamoDB fetching from the database. Frequently accessed keys can be fetched from the Redis cluster itself only, right? But for them, it is agnostic. They understand, okay, I'm just offering the database key value storage as a managed service. It is agnostic for them how it's coming, but they are caring for the given a key a value, right? Now, okay, what left? Okay, we have spoken to the partition lookup service, different partition strategy. Now let's just talk about the database design. It's a very small part. And the database design, yeah, we in the each of the nodes, what we maintaining it a single key value table. Key would be a partition key. Value would be a sort of a blob, kind of a string. Blob in case if it is an opaque as well also, and it could be a string or JSON if we are uh, persisting the structured format. Okay, right? We can support that as well also. So. And there is other columns like created and updated at, right? Now we are choosing the key as a partition key here, given a key. Now ideally, every key is a unique key, and if it is not a unique key, it means it's supposed to update the existing key. So every key is sort of in a unique key, right? So every key would be as a new, as a sort of in a partition, a new, as a separate partition, right, into the database node. Though we cannot have a one-to-one mapping for each key, each partition. We can have a separate node. Hence, we use a consistent hashing to map that to the existing node in these set of a nodes only. So each node may hosting the number of a partition, and out of them, some would be a leader and some would be a follower, right? So that's how it is. Yeah? Now we have almost covered everything. Do you have any question to ask, Vishal?
Can you explain one thing again? Like, how is the read complexity order of one in this case? Like, we can find the node, but in each DB, we have to search for that particular node, right? Particular key.
So, okay, when you, so every partition is just treated as a database into that. though we may have different
Right.
number of a partition on that node, but every partition is a separate
Okay.
database entity, right? So
Okay.
I mean, but how many it could think of like distributed there's a hash table,
Okay.
a node is
Hmm.
hosting a one of the hash table, and that how many entry partition it can have, 1,000 partition, 10,000,
Hmm.
but it would not be more than that of it, right? But yeah, it can
Right.
have lot of, I mean, I think I was wrong. It can have a lot of partition, right? Because we are supporting 1,000 requests per second, and we may have a billions of keys in our system, right?
Hmm.
So billions
Hmm.
of the partition we may have in our system, right? So every node would be, but every partition is being treated as a separate database uh, uh, in that NoSQL way. And we ideally shouldn't be much of a complexity to figure it out within that node. Now it has to do the key comparison, if I'm not wrong, right? So
Hmm.
it can figure it out uh, uh, probably in the constant time, if which partition it's in this node this key belongs to, right? We should not be concerned of that because those are being taken care by I mean other primitives sort of things, like, and is also one of the solved problem. But yeah, malab, when we are talking about a distributed key value storage, the expected latency that we expect is, I mean, we think of it like in a distributed hash table, right? And in that
Right.
distributed hash table, uh, the amortized complexity, the average comes always order of one.
Hmm.
For some cases, it can be high, some cases it can be low, but amortized complexity is order of one only, right? So that's how it is. Okay, any other question?
No. Thanks.
Okay, guys, thank you. Hope you enjoyed system design of a key value storage with me. I am very excited to bring new topics, new system design topic as well also in the future, right? And meanwhile, stay tuned. Thank you so much for watching this video.